So, welcome then to the last session of this Gradle Summit. I hope it's good to see some of you here. I think I brought something quite interesting with me. My name is Reimer. I'm a chief technologist. I work for QAware in Germany. We're a small project house. We're 80 people. And I want to show you today how we used Gradle in-house to revolutionize the way we build our software development environments. Okay, so this is why this session is called Lightweight Developer Provisioning with Gradle and SEU-as-code. So what that means, the acronym, I will tell you in a second. So what do we have planned? So first of all, I will talk you through the background and the motivation why we did this and what's the whole purpose of this. Then I will show you how to build an example SEU, and I tell you now, SEU is a German acronym for software development environment, okay? So we do that in 15 minutes. I will then quickly talk you through the conventions and plugins that make up this whole approach, this whole tool. I will talk you through some SEU customizations, and then finally I will show you how to build software packages with Gradle, so to round things up. Yeah, I already said it. The thing is called SEU-as-code. So SEU, that's the first letters of Software Entwicklungsumgebung. So that's German. And it stands for Software Development Environment. Okay, so it's not only the IDE. It's basically everything that makes up your software development environment if you're on a project, right? So you have the Java version, you have the IntelliJ, you have Gradle as a build tool, or maybe another build tool. You have a Tomcat, a Solr, or some relational database, a Derby, or whatever. So this whole thing together that makes you productive to build a project for a customer, this is what we call a SEU. Okay, so I will use this acronym quite often now, but you know what it means now. Okay. Well, colleagues told me SEU is a strange name, and consider English people and they don't know what this is. So I thought, well, SDE for Software Development Environment is also strange. It's not a common acronym, right? So I figured, well, sod it. It stays the way it is. It's SEU-as-code. What we think, software industrialization, I don't know if this is a common term. We have this term in our company, and software industrialization is not about cheap labor and offshoring development work. Okay, so I would say this is software slavery. Software industrialization is about automation in the end. Okay, it's about making you more productive. It's about producing higher quality products. It's about producing higher quality projects. So it's about the automation of repetitive and laborious tasks. You don't want to do them all the time. You want to be efficient. You want to get rid of those. You want to concentrate as a developer on producing the actual product and not doing all those boring tasks. Better software quality in the end is one big goal of software industrialization, and you achieve this via a standardized and streamlined tooling. Okay, I always compare this to a conveyor belt. When Henry Ford, I think, when he started to produce cars, at some point he realized that he needs to change something to produce even more and to have more outcome and more output out of his factories. So what did he do? Well, he introduced the conveyor belt, and he introduced like a standardized, first here is the car assembled, here you have the chassis, then you, insert the doors, then you have the bonnet, and then you insert the engine. And this is kind of can be applied to software development and software engineering as well, I think, okay? So this well-integrated tool chain then leads to a higher productivity of your team, because everything fits together nicely. And in the end, you're faster from, your sprint planning to, your definition of done. If you're in an agile mode, then, you can, you produce more and at a better quality. And I told you before, we're a small software house. Okay, we're only 80 people. We pay our people quite decently, I would say. We have a lot of competitors. They're definitely bigger than us. I do work a lot for this German automotive company stationed in Munich, the one with the 3 letters, okay? So do work a lot for them, and our competitors are really big ones. They're the Accentures, the Capgeminis, the MSGs. I mean, they have like 4,000, 5,000, 6,000 people, okay? And they can always beat us on the price, okay? Because they have cheap labor. We don't believe in cheap labor. We believe in good working conditions, so we pay our people well. So we need another way of, well, being cost efficient, okay? And for us, this is, well, better tooling, standardized tooling, streamlined tooling. And in the end, we are competitive, definitely. I mean, we sometimes beat them, sometimes we lose them because they're cheaper. I mean, that's the name of the game anyway. Yeah, so software industrialization, I think, is a major part. And the whole DevOps thing that's going on at the moment, it's about automation and software industrialization as well, in my opinion, okay? And SEU-as-code is at the very beginning of this whole development, of this whole delivery process, okay? It's about setting up the work environment for a project for our software developers. We sometimes compare software engineering or our craft, we sometimes say we're software craftsmen, right? Is craftsman the correct English word? So we want to produce something, well, something really shiny, really good, really well manufactured. And if you look at this here, you have the workbench of the craftsman and all the tools. They're sharp, they're well oiled, they work. So this is how it ought to look like. Okay, so maybe you have your IntelliJ IDE there, and you know all the tools. But what I find is that it often looks like this. Okay, so for some reason you have this mess. And I had worked for quite a few companies previously where it was like this. The developer was on his own, and the developer had to set up his workplace on his own, and then he went from one project to the next project to the next project, and he never had the time to clean up things, okay? And obviously after a while you have this big ball of spaghetti tools, well, polluted with the previous state of the previous project, and then you continue. So this is mostly the reality, and this is something we wanted to change in our company. Well, what are the problems of this? So the obvious thing is, if you have individual software development environments, well, they kind of produce different results and often strange bugs. I mean, how often have you debugged a, well, supposedly software bug in the product you develop, only to find out that this is a very, very local bug on this one developer machine with a strange combination of Java version combined with strange Derby version, I don't know, combined with a strange library. And only to find out, okay, it wasn't a software, it was actually your bloody PC that made the problem. So the next thing is, I mean, the way we worked, well, 2 to 3 years ago was, what we usually do is we have a virtual hard drive, and in this virtual hard drive per project we have the software installed. So that made things a little better. So it's kind of a container approach, okay? It's not Docker, but it's kind of a container approach on a hard disk level where all the tools are installed. But you know, time is always pressing and you're lazy, so what do? Well, you copy the development environment container from the previous project to the new project, you make a few adjustments, and then off you go again. So you're kind of not only a little better than the mess we've seen before, okay? So again here, this is something we wanted to improve. Next thing is that older versions of such a development environment cannot easily be restored. I mean, project moves on. The current project for BMW, now I say it, is quite a long runner. We're there for the 4th year now. And maybe you have to go back like half a year in time to fix an important bug. But how can you restore the development environment you had half a year before? Impossible, right? If everything's installed locally, how can you? So in our opinion, a software development environment, well, needs to be versioned as well, just like a source code. Then the manual and error-prone update process. Okay, I mean, we have a team of 25 people on this project, and we just upgraded from JDK 6 to JDK 8. Woohoo! finally into the future. So how do you do that? Or how do you change from, well, the previous version used Glassfish 4, now we know Glassfish 2, now we can use Glassfish 4. How do you update this? Let everyone do it on its own, then you have individual installations again. So not the solution. And then there are those tasks you have to do. You have to initialize your local database with some test data, perhaps with a test script. So you load into this. The current project is using Solr, for example. How can you distribute this test Solr data to the machines of 25 people? So far we receive them in batch files, okay? And I need to be honest with you, I personally hate batch files. Perhaps I'm spoiled, but I want a proper IDE, I want a proper programming language, and batch files is no proper programming language in my opinion. So I want something nicer. I want groovy. I want, well, maybe JavaScript, but maybe better groovy. You have a question?
We're thinking about using Debian like this.
Yes and no. First of all, most of our developers are on Windows, so no Debian packages then. What we see now is that a lot of our developers, well, they also want Mac as well, so Debian package, again, not so. So we're not a Linux company. But for Linux, it would have been an option definitely to move to, well, some native packaging mechanism, for example, yes. And what you will see later is that it's kind of comparable anyway. I mean, it's a similar approach, but solved with Groovy and Gradle. I mean, that's the whole point why I stand here today. So we wanted to get rid of those batch files to customize and the behavior and to add tasks and to add functions to our software development environment. And then it's always funny how those things come together, right? It was me under the shower thinking about the new project. You know, I always stand under my nice huge shower where I get the best ideas. I just read the Gradle in Action MEP by Manning, so I had that as well. And so I was thinking about, well, I want to build software development environments. And then I thought, well, if I say that, I want to build something, well, how about I use a build tool for that, okay? Quite clearly, Maven, well, I know Maven quite well, and I thought, well, better not try that with Maven. And I had read this book by Manning, and I thought, okay, let's give that a shot. Let's give Gradle a shot. Let's get Groovy as a language a shot. You know, we'll keep trying it. They say they can build anything. Well, okay, let's prove it. If we can do this. So the idea was, well, as it says here, Gradle Tasks and Groovy are used for the instead of the shell scripting. We want to get rid of this one. Everything can be version controlled. Okay, if the only thing I do is write a Gradle build file, then of course I can check this into Git or SVN if you like, and version control this. And you have this jumping back and forth in time for bug fixing, for example. The required software packages, that was the idea. They are expressed as normal dependencies. Okay, I mean, you can do anything with that. You can have transitive software packages. If you install an IntelliJ, of course you need some form of Java. Okay, so you need a JDK8 if you like. So you could have transitive software packages as well. So, well, those dependencies should work. And the software packages should be stored in an artifact repository, okay? Nexus in our case could be Artifactory, it doesn't really matter. So all the infrastructure you have anyway as a software company or as a software project house like we do. Yeah, so this was the idea, maybe the solution. So now I want to quickly jump into a demo. I said in the abstract, I want to show you in under 15 minutes that I can produce a running software development environment. So I prepared a short video, or I can do a live demo. So what would you prefer, watching a movie or see me code? Yeah, you don't mind? Okay. I prepared it so much, I feel confident that I can do it live, okay? Yes, yeah. And then things started to explode. Okay, I do this on a Windows machine because this is the way it works best now. I could have done it on the Mac, but a few plugins don't work quite well on the Mac yet, so I do it here. So can you see everything? Yeah, I think so. Okay, I said what we use is, okay, let me time things, right? Or is anyone timing for me? Start, okay. So what we do is, I use a tool called VHD attach. You could do this with Windows functions as well. But what I do here is I create a virtual hard disk. I say it's 20 gigabytes of size, maybe 25. You can make it self-expanding, dynamically expanding. So I create this file. I give it a name. I call it Gradle Summit 2016. Okay. So I mount this file. Okay, see here, I have my. Okay, so that's always the problems with live demos, right? Here we go. We need to format it. We do okay, and off we go. So all I have now is a new hard disk, which is mounted under G. So what I have prepared here, so see this here is the GitHub pages. I go to the Archetype, which is kind of it's kind of a template, a project template, which you can use to quick start your projects, right? So if you want to reproduce this, here's a quick start documentation. So I go to the release page here. I download the Archetype. Yes, network is working. So I extract that one. I go here. Well, this is convention. I renamed this to SEU base. You could technically name this anything you like. So here you see a prepared. Can you read this good? So this is the Gradle build file. Okay, I have a few plugins here. I have the base plugin, which makes all the magic. I have a so-called credentials plugin, Git plugin. We won't be using the SVN plugin today. So the SE root is G. We give it a nice name. We go a bit further down. We don't need this here. So here are the repositories you see, Maven Central. I have a bin tray repository where some of the packages are. So here's where the flash is. We have the dependencies. So the first two are required by the base plugin. I have a home and a software configuration. We do not need this here. No, we don't want and. We don't want Maven. Well, we leave Tomcat out for now. We don't need JRuby or Scala. So what I want is, well, I want to install Groovy 2.4.4. I want to install Gradle 2.5, and I want to install the Windows version of msysgit. Okay, so this is how I describe my software dependencies, my software packages. I open a console. Can you read that as well? Okay. Gradle U. We say Gradle U bootstrap SEU. And off we go. So this is the part where I do, okay. See, we have a resolution error. Yes, that's true, wrong version here. So this is normal Gradle behavior. It didn't find a dependency version, so I corrected the version now. It starts downloading a bit of the software because I did the dry run beforehand, and I kind of in the process now would have had to download 750 megabytes. I figured I do a dry run, otherwise we would sit here tomorrow morning with this Wi-Fi. So the SEU is bootstrapped, and if we look at our G, now we see we have a lot of directories. We have something called codebase. This is our convention for, this is where all the projects are checked out. We have a doc base. This is where our documents we usually do. We also version our documents. We version every PowerPoint slide. We version every Word document, whatever throughout a project is also versioned. That comes into doc base. home repository. This is the local Maven repository, SEU base. And here we have the software directory. And here you see we have Git, Gradle, and Groovy installed. Okay, so this was 4,050,000 and the first version is already running. So what you could do now, or what you should do now, is to version control everything, right? So you add this to Git now, you commit this to SVN, whatever you're using. Okay, so let's say we've done that, and let's say we want to update things now, okay? First of all, the Gradle version we're using is terribly old, okay? So we want to use Gradle 2.13. Yeah, and our project needs a Tomcat now. And let's see what else there is, okay? So we go back to GitHub. We go to the packages repo. So we see here there are quite a few packages already. And well, Elastic, yes, we need Elasticsearch. See here, we can download version 1.7.1. As you can see here, all those packages are Gradle builds as well. I will show you a little later how to, well, build those packages. We take this one, we insert that one, we go back to our console, and we do update SEU, okay? So again, we're here applying the software we just did, applying the software dependencies, and hopefully in like, you know, a couple of seconds, 14 seconds, we're, well, ready to go again. If we look what changed, see here we have a few shortcuts here. We have a Tomcat 8, we have the Elasticsearch. If we look at the software, you see that we upgraded the Gradle version from 2.5 to 2.13. And again, once you did that, you would version control this again, check this in, give a ping to all the developers. The developers would then say SVN update or git pull, and also apply this Gradle update SEU to their local version. Okay, so this is the way we distribute changes of the software development environment into the whole team via the normal source control, right? So back to the shell, if we would say, okay, what do we have here? Okay, of course we could say, give me all the tasks. Now you see a bit of what's going on here. Here we have a few version control tasks. You already saw the bootstrap SEU and the update SEU task I showed you. Of course, there's a destroy SEU, which I hope you will never need, but it's there for completeness. And we have a cool create ASCII banner task here. Now, this is my most favorite feature, to be honest. So if I open a console here, you can read here SEU-as-code, okay? But obviously this SEU is named differently, it has a different name. So what we do instead is Gradle, we create an ASCII banner. It takes a time. We go back, we open a console, and yay, we get Gradle Summer 2016 as ASCII art. Yeah, okay. We need some fun as well. Thank you. So what's next? There are a few other things which we can do. Now the software packages currently, they're mostly open source packages, but of course, I mean, we use IntelliJ, for example, IntelliJ Ultimate Edition. I mean, this is not a free product. So we have a package of this, but in our internal repo, in our internal Nexus, okay? So I will show you how to kind of do this, okay? So what we need first is to specify a new repository in our build file, right? So we do URL, we do https Nexus content repositories. Oh, a lot of typing. Okay. And of course, this is not an open Nexus, right? We need some credentials for this. So we have a username, well, Bob, and we have a password, which we type in here as well. Now, if I would commit this, this would not be such a good idea, right? I mean, first of all, the username is dependent on the actual workplace you're on the actual developer, and hopefully he does not commit his password in the file, or maybe he puts it in a Gradle properties file, but that doesn't make it any better, right? So what we need here is I want to show you the credentials plugin. Okay, that's the second one. And this is the part where it gets a little, well, platform specific, because this current version only works on the Windows. What we can do is we say project.credentials. We say Nexus username. We copy that one. Okay, and we say Nexus password. I show you in a minute where this comes from, okay? But basically what this credential plugin does is encrypt the username and encrypt the password using the standard Windows encryption API and store it encrypted on each PC. So every developer has his encrypted credentials on his machine. And here in the Gradle build file, you just say project credentials, give me the username, give me the encrypted password. So this only works on every machine. Even if you would copy this file, it would not work on a different machine, because this encryption is machine local. This is the way the Windows encryption works. So we wanted to install the IntelliJ version. Let's see if that is the latest version. JetBrains 2.16. So we do that. We do copy. Oh no, that's the wrong place. Up. Okay. So we do that. We go back to our console, and we do update SEU again. Now, luckily I've done this before, so this would be 350 megabyte. I think this this dependency. While this unpacks and installs, I quickly show you where this is stored. So the credentials plugin creates a file which is called secure credentials, okay? And I can show you this, okay? And you can even copy paste it, but you will not be able to decrypt it without my machine. Okay, so here you see Nexus username, Nexus password are those encrypted values. So this is the way we think it's secure to check in, to version control your Gradle build files at places where you need, like, you know, some form of credentials, but those are local to each machine. So let's see, we're done. Okay, let's go here. Okay, we have IntelliJ 2.16 installed. Yep, do not have a previous version. Takes a bit just to show you. So this is. There you go, up. And maybe you can spot it now here, okay? So this is licensed to me, QAware, Mario-Leander, Reimer. So this is my license. Okay, so that was IntelliJ. I think you get the point how we do software handling and updating and bootstrapping. One final thing I want to show you is, you saw in those tasks that we have some version control tasks. See here, we have a git clone all, git clone code, git clone docs. So where does that come from? So if we go back to our build file, you see here at the top that we include a script file here. So let's open that one. So scripts, git. Okay, so here you have this git configuration. We configure the code and the docs, and it gets its URLs from a property file. So let's see where that is. Up. I mean, this is all convention. In the end, this is nothing we say you have to do it that way if you think you want to use properties, or you have to use it, you want to have that inlined into the script. This is all fine, right? So what we do now instead is, let's get a URL. So we go to the Archetype, we download this one, we copy this one. Well, I kind of check out both the same now, okay? We can Archetype documentation. We save that one. Up. we do git clone all. 20 seconds left. So it does git clone code. I have network, yes. So if you now see here in the code base, for example, we have now checked out the actual source code of the Archetype, for example. I mean, this is something you do at the beginning of the project, right? Afterwards, you have a nice GUI if you have source tree or something to manage your Git repositories. But if you want to bootstrap the initial thing, you know, then this is a quite handy feature, especially if you have a multi-repo setup where you have like 10 projects perhaps. You do git clone all, and after that, you're ready to go. So 15 minutes, 24 seconds, okay? So I stop here with the demo. Now, seriously, this is the way we create all of our software development environments now, okay? So I don't know of any project which doesn't use that. And if I go to a conference or something and I even build a small, nice and cozy software development environment just for this, for my demo code, for my slides and all that. And it's nice and easy, you know, 15 minutes, and you can even do it even faster, right? If you've done that a couple of times, then so let's move back to the slides. So that was a demo. As I said, I had a movie here. I uploaded this one to the portal, so you can watch this 15 minutes movie. Exactly the same as I showed you now there. Okay, so let's talk you through some of the details. Okay, a lot of the things I just didn't cover now. So I told you that the main plugin is the so-called base plugin. Okay, this does the heavy lifting. This does the bootstrap, the update, the dependency handling, the unpacking, everything of this. And the most minimalistic thing is this here, okay? You apply the plugin using the new syntax, and then you have here the configuration, which is called SEU-as-code, and the minimal thing you have to specify is the home directory and the project name. Well, the project name is optional anyway, but without the project name, you don't get the ASCII banner, right? So you need the project name. So the home can be anything. It can be a directory, okay? If you don't believe in virtual hard disks, then use a standard directory. And on Macintosh, you would use a sparse image file, okay? So this is also possible on Macintosh. Never tried it on Linux, but it should work. I mean, Gradle does work under Linux, so there's no reason why this does not work under Linux, okay? So this is the most minimalistic thing. Then you get the directory layout as I showed you before, okay? But of course, there's a little more. So this whole thing is, well, lives from, of course, default values, convention over configuration, right? But if you want to change it, this is the way you could do it. So currently, the layout is as following. Well, you could decide I don't need a home, then you could leave this empty, then this will not be created, that directory. So those are those, well, 1, 2, 3, 4, 5, 6 directories which we find most useful. We have a directory where we have the code, we have a directory where we have documents, we have a home directory, the repository where we want to store all our locally built artifacts in the software development environment, okay? So we don't want to store this under .gradle somewhere or .m2, .m3, whatever it is. We want to store those local artifacts in here, okay? Software and a temp directory, you know, that's my most favorite working directory, the temp directory. So there's a Datastore option. I hardly never use this. This is just for, well, I kind of wanted to learn Gradle and Groovy, so I figured, you know, we make it nicely configurable, and only having an H2 database is, well, not so cool. So we do support, I do support mapdb as well, and it's pluggable, so you could easily insert something else in here. And this actually is a JDBC URL. So if you add another JDBC driver to the class path, and you provide the correct URL here, like then you could technically use a Derby database as well, or an Oracle if you like. But I think H2 is pretty good here. And here, of course, the banner, you know, if you don't like the font, if you want reflection or you want to have it left aligned and you want to have it stretched or the width, then of course you can tweak the ASCII banner here, yeah? Again, important section. So I showed you here, this generates our nice ASCII banner. Now this is where the heart is, okay? The software dependencies. And you see that here is home, here is software, that those configurations here, they match the directory names of the layout, okay? And this determines basically where this dependency will be unpacked into. If you write home here, this software dependency will up in the home directory. And if you write software here, this software dependency will end up in the software directory. So quite simple, to be honest. Most of the open source things are, I told you before, are in this bin tray repository, but I only upload those packages there where I think the license is. So MIT and Apache license is okay, so I upload those there. Anything else is too, well, didn't want to offend anyone or didn't want to break any license, so I figured, you know, MIT Apache is good, upload those. Anything else is probably better in a private company repository. So yeah, there's not much to say for those, for the dependencies. Maybe one thing you see here, this one here, for example, uses a classifier. This would be my tip to use if you want to, if you have, well, platform-specific software development environments, okay? If you have a package that can only be applied to Windows or a package that is specific to Mac, then I kind of think one can use this fourth coordinate here, the classifier. Yeah, so this is the section where you work most probably if you want to install software. I quickly showed you the Git plugin. You can use this independently of the base plugin, by the way, okay? So this has no dependency whatsoever on managing your software development environment with the base plugin. So this can be used standalone as well. So in this Git section, you can specify multiple repositories. The name here then determines how the final tasks will be called. So if you have a Gradle repo here, okay, then you will, for Git, get a git pull Gradle, git push Gradle, git clone Gradle, plus the added git clone all in case you have multiple tasks here. I think nice and clean syntax. That's the whole point of Gradle, having to write less and in a more expressive way. The same is possible for SVN. Again, no dependency on the base plugin. You can use this standalone as well. And it looks the same as the Git version, okay, and it kind of works the same. The only thing that the wording is a little different, okay. You don't have clone and pull and push. You have like checkout and update and commit. Yeah. So this is the only thing that really changes here. For both of them, you don't need a locally installed Git or SVN client, okay? So the Git plugin uses JGit, the library, and this one here uses SVN-kit, the Java version of this. So this works even if you have no Git or SVN client installed on your machine. Right, so secure passwords, I told you before. So this one here encrypts your passwords using the machine credentials, the machine secret key, which is currently unique to Windows. You see here, down here, Gradle use set credentials. This is how you encrypt your credentials, and then they get stored in that file. I'm currently working on the Mac version, because on Mac you can also put those stuff into the keychain, into the key manager there. I'm kind of working on that one.
Public key support? Public key support?
Well, good idea. I will file a GitHub issue for this one, feature request, and we can work on that one, of course. Yeah. I mean, the whole thing is kind of lives of the requirements so far we had from the company. Okay. But of course, and this is why I'm here. Of course, there are a lot of good ideas in the community, and well, let's work on that one. Yeah. So SEU customization. This is quite cool. I mean, this is what I told you before. I don't want to write shell scripts anymore. I want something nice. I want an IDE. I want content completion. I want code completion. So Gradle build files are scripts. Be creative here. You can do almost anything. You have copy, xegg, sync. You have so many predefined tasks you can use to make up your tasks. The first version of SEU-as-code was, by the way, was not even didn't have any plugins. It was one big build Gradle file, 370 whatever lines of code, and it did work. And then I refactored it and made all the plugins. So that kind of convinced me, okay, if I can do this in a Gradle build file to create an SEU, then this is going to be a good idea. So here you see some tasks to mount Windows network drives. Well, we use xegg, we call a command, not very spectacular. Here you see an example where I delete or initialize a Derby database using an SQL file. Not spectacular. This is just some samples taken from real projects, right? This one here, for example, is a bit more complicated. It initializes a Solr instance from zip files, okay? So we have a lot of zip files that zip up different Solr cores, and basically this task here, unzips everything to a certain location and creates dynamic tasks here, which you can later execute, okay?
I really like the sync task which you've used, because unlike unzip, it's always up to date if the source zip hasn't changed, but sync will always blow away the destination.
Yeah.
Which when you're copying files over, it's a behavior sometimes difficult.
Exactly. So this is just to give you an idea. I mean, you can, this is very SEU specific now, okay? So the things you want to do, they change. Okay, so short in time, building software packages, okay? In the end, they're all plain jar files, okay? Upload them to a Nexus. Currently on GitHub, there are 44 package builds, Gradle builds, okay? And of those 44, I uploaded 26 to Bintray. As I told you, commercial packages are better off in your private company repo. And to my experience, it takes 15 to 30 minutes to build a package if it's not there. So this is basically it. I mean, how do you install a Derby or a Tomcat? You go to the website, you download it, you extract it, you copy it to your local hard drive, and then you're ready to go. And pretty much we do that here as well. We download, we unpack, we customize, we repackage, and we publish. Okay, so let's do that. We download. We download the Gradle 213 all zip. We download that one. Easy. We unpack it, extract, we do a copy task, zip tree, we unpack it. Now, customization is, very different from package to package. Sometimes you don't need customization at all. Sometimes you want to add some extra shell script. Sometimes you want to use scriptom to create a nice Windows shortcut in the root directory of your SEU. So this is how you would do this here. You package everything again, type jar, you build everything up. So this is the final artifact done. And then you use Gradle Publishing to publish it to whatever repository you want to do. In our case, it's either, as I said, Bintray or your local Maven repo. So this is the publishing. So what's next? I even have one feature now, one more feature for the credentials plugin. So Mac is definitely on the roadmap. A customer of us, which is German Telekom, they have a team, we have a team, they work with Mac, we work with Windows, but we will all work on the same project. It's a home automation project. What we want to do is, have the same build file and create their SEU, create our SEU, so we're kind of consistent there at least. I want to add more and more software packages. This is like an ongoing project. Every new project adds new software packages, so this is natural. I told you about the plugin to securely store the credentials on OS, or maybe now with public-private key things. Maybe create a build plugin that builds software packages, because this is all boilerplate at the moment. Okay, so this can be done quicker. Yes, and the good old improving documentation thing, right? There is some documentation, at least in the README files and in a wiki. I'm working on a separate online documentation at the moment, but you know how it is. Writing documentation is always the last bit you do. So yeah, contributions highly welcome. Everything's online. Here the URLs of all the repos. So there's the repo for the Archetype, the plugins, the packages, some example SEUs if you want a quick start, and here would be the user guide to, well, for the online documentation. Yeah, thanks for your time. Little overtime, 1 minute. Hope you enjoyed it, and yeah, that was the last session. I think we have one thing to go. Thanks. So, if any questions?
Very cool.
Thanks.
Did you ever have a case when you're unzipping software packages where one may overlap the settings of another and you need to maybe not merge but prioritize, like some A covers B or something like that?
No, because in this jar file, mainly you should have one unique, well, every package has one unique version, so there is kind of a way, if the package is called Tomcat-8.1, then the directory installed this is also Tomcat 8.1, and then it should not clash with a different one. So far I didn't have that. Okay then, thanks guys.